Hi folks, today we'll be going through this presentation about demystifying edge devices, cloud native storage for different data sources. My name is Umang Kumar and I'm from Hewlett Packard Enterprise. I work there as a master technologist. And with me the co-author is Subhadeep Das, but he's not present today, so I'll be taking you guys through the entire presentation here. So let me go to the next slide. So we keep hearing this thing, right? That edge is going to be the new core. So Gartner predicts that by 2025, 75% of enterprise-generated data will be created and processed at the edge, which will be outside a traditional centralized data center or a public cloud. That's up from just 10% in 2018. So back in early 2000, where most of the data sitting in the private data centers, then in early 2007, some of the data started moving out of the data center. Example was AWS, and then later most of the data were generated or created inside a public cloud. Now we are talking about edge computing, where data will be created outside the centralized data, outside a private data center or a public cloud. So since data will be created at the edge itself, we need to groom the data at the edge itself and be ready to be able to take actionable measures based on the user feedback at the real time. With the increase in the size of working data set, which would need real-time insight at the edge. Let me go to the next slide. So one of the important thing that will be the big time enabler for the edge new use cases is going to be the 5G. So 5G is going to bring the data explosion because of the speed, scale, and stability at the edge. 5G is going to bring a lot of new use cases at the edge. If you compare the key statistics difference between 5G and the 4G, you will see that here in the slide that we are talking about a peak data rate which is 100 times faster than 4G, latency which is almost 50 times lesser than 4G, and connection density which is almost 50 times more than 4G. So as I just discussed, with a theoretical peak data rate which is up to 100 times faster than 4G networks, the 5G holds the promise of enabling incredible new applications and use cases such as autonomous vehicles, telemedicine, and the ability to share potentially life-saving high-resolution medical imaging, just to name a few. And these are going to be the new edge use cases as and when the 5G infra started coming out. IDC also predicts that global volume of byte data generated annually is projected to triple between 20 and 25, and 5G is going to be the biggest contributor. Now we talked about the data explosion at the edge, right, and the 5G. So little continuing here from that angle only, that today more than 5 billion consumers interact with data every day. By 2025, that number will be 6 billion or 75% of the world population. In 2025, each connected person will have at least one data interactions every 18 seconds. So that kind of nailed down that what kind of data explosion that's going to happen in the coming down the line 2 to 3 years. And all the new use cases at the edge is continue to generate data at an exponential rate, whether it's a video streaming or a smart sensors or the connected car, each can potentially generate terabytes of data per day. Now the question is, what do we do with all this data being generated at the edge? We cannot wait for this data to be generated at the edge and later be stored and processed at the core data center. We need to provide real-time data insight at the edge itself, instead of that data to be stored and acted upon later in the core data center. So let me go to the next slide. So if you see the edge infrastructure here, we are talking about 4 different four different infrastructure in the edge. We are talking about here a edge and an IoT device. Then we have a on-premise edge. Then we have a network edge or a telco edge, or a few people call it as a cloudlet also. And then we have a core data center, which is either could be a private data center of a customer or it could be a public cloud-based core data center. Now what happens, like you have edge devices like car, mobiles, and video cameras generating those huge amount of data which via 5G lands into on-premise edge. The job of on-premise edge here is to perform data acquisition and processing of data at the edge. The network edge does the work of data aggregation. Network edge does the work of data aggregation and movement of data between on-premise edge and the core data center. As I told just before, that core data center could be the customer a private data center located at a particular region, or it could be based out of a public cloud located at a particular region. Now let me talk a little bit about the architecture or the hardware architecture of each of these edge infrastructure. Now let's start with edge devices. So driven by the economic consideration and form factor, an edge devices typically has a limited computing capabilities. You will see typically, so these edge devices are based out of ARM or x86 based processor, and typically have 1 or 2 core CPUs with 180 to 128 MBs of memory and some GBs of local storage. These edge devices are capable of running basic analytics and AI ML rules, and also has capability to store data locally to support operations at the edge. Now let's talk about on-premise edge. These are also called as edge servers. These are racks. These are general purpose rack of aggregated computers, typically located in the remote facility such as hospitals or in a hotel, or could be in a bank, or it could be in a retail store. They typically have higher computing power based off 8 to 16 core, typical example could be 8 to 16 core CPUs and GBs of memory and then higher GBs of storage. The job of on-premise edge is to deploy apps to the edge devices. They are in constant communication with the edge devices through the agent installed in each of these edge devices. And so if any edge device's data requires more than basic inferencing, then those data basically lands into the on-premise edge for further processing and grooming. Now let me talk about network edge. So network edge basically act as a local cloud for edge devices data. So it reduces the distance. It reduces the distance the edge devices data has to travel, and in turn help in reducing the latency and taking into helping the bandwidth consideration. So a typical network edge has an enterprise grade storage management and storage device management feature, and much more analytical and AI ML capabilities. Now let's come to the core data center, right? So again, the core data center is going to be the main data center in this edge infrastructure, and this is the final destination where data generated at the edge will land into. And the data that comes here will always be processed and the groomed data. And this provides you, the core data center normally have enterprise grade storage management, device management, and enterprise grade analytics and dashboards capabilities. So now the question is that, how will it all work? How does the entire edge infrastructure is going to work? So here, if you see that, on the left side, you have all those edge devices right from your cameras to mobile phones to cars, generating those data that via 5G lands into a edge node, which then gets stored there in the local storage. Now, if you see those data, right, that can be categorized into different types of data. We are talking about a stream data, object data, or it could be a file and a block data. Now, stream data is basically is a set of data that is continuously generated with high volumes and high velocity, forming millions of records and tend to form a data stream. So a typical example of a streaming data could be a JSON or XML key value pairs. Now you also have an object data. Object data basically stores the data as it's an unstructured data and basically stores the data as an object. And it provides you the limitless scale when you compare to a file storage. Today, object storage is become the go-to storage for any public cloud vendors. If you see any of the public cloud vendors, it is the primary storage offering today in the market. Now, the traditional file and block data, we all know that it's been there for a long time. So basically, the data categorized into a stream data, object data, and file and block data. Now, what we do with all this data? So this data, we need to bring those core data center processing at the edge itself. So what happens is like this data basically gets processed and groomed at the edge itself by running those analytics and AI/ML capabilities. Now, what happened because of this is that now you have two kinds of data after processing and grooming: a data which is not important, and the data which is useful. Data which is not important, basically, what you do with that data, you either discard that data or you move it to the secondary storage. And the data basically that is useful, or the groomed data that is identified for a long-term use, is basically moved to a core compute and storage, which is basically the core data center region. So now let me talk about the cloud native architecture at the edge, right? I mean, with huge amount of data getting generated at the edge, right? There is a talk about how to bring cloud-like ecosystem model at the edge itself. How to bring those kind of cloud-native way of design and methodology throughout the edge infrastructure. How architecture can be designed based on a microservices-based design rather than a monolithic architecture. One thing is sure that Kubernetes is becoming an underlying operating system, going to become an underlying operating system for managing the edge infrastructure. The role of Kubernetes here will just not be limited to powering on the cluster of containers, but the Kubernetes ecosystem and tool provides much more than that. That includes the deploying, maintaining, and securing the edge infrastructure. As we move towards the edge layers, the number of Kubernetes cluster and containers increases multifold. We are talking about thousands of Kubernetes clusters. So managing those is a big operational headache. So there is a need for centralized and streamlined Kubernetes management and service for our architecture that can be managed through the GitOps operation. So as we discussed in the previous slide about the edge architecture, right? So basically we need to have a data platform that manages your data and that stretches from edge to core data center. Now within that, right, you can have a multiple flavor of it. You could have a public cloud-based data platform where the cloud vendors provide their own stack like Azure Stack, AWS Outpost solution that can be placed on-prem at the edge location. And then that can be extended to public cloud as a core data center. Now you also can have a private cloud-based data platform where vendors like HPE and IBM provides their hardware and solution at the edge location, and then extends it to customer core private data center. We also can have a hybrid cloud-based data platform where private cloud vendors provide their hardware and solution at the edge location, and then extends it to public cloud as the core data center. So these are the different ways edge infrastructure can be deployed across, whether it could be a public cloud base, could be a private cloud base, and could be a hybrid cloud base. Now we discuss about the requirement, right? All the hardware architecture for different edge infrastructure. So if you see, right, the storage requirement, right, a typical edge and IoT device will typically comprise of 0 to 32 GB of storage, and then your on-premise edge will have a storage in the low terabytes capabilities. And then we talk about a network edge, which is a local cloud for edge infrastructure. You have the storage requirement in the high terabytes range. And then you have a core data center where we are talking about storage requirement, which could be in a petabyte range. So now question is that how do we design the edge storage, right? What does it mean for the edge storage? So one of the key thing is that we definitely need a faster storage interfaces, something which gives you ultra low latency, like lesser than a millisecond, and technology like NVMe is going to be a table stake, in this regard. Then we also need to look for a storage solution which should be a totally cost optimized, since the form factor at the edge location is an important criteria, the solution should be denser and also should be highly available. And since different kind of data gets generated at the edge, we also had to look for a customized offering for different and unique data. We also need to look for operational simplicity and agility, like a public cloud on-prem edge nodes. And also, as the data flow through the edge infrastructure, right, we need to work with a set of rules where we work with most recent data, keep the important data, discard the rest, so only the important data goes and land to the main core data center. And for the streaming data, right, that we just spoke about, we need to have different kind of architecture like AWS, Lambda, Google Functions, Apache Flink to generate real-time insights on the streaming data that gets generated in the edge. So today, right, if you talk about the cloud-native storage options at the edge, and we specifically talk about the cloud-native Kubernetes-based storage through the container storage interface. So CSI provides vendors of, especially the file and block storage vendors to define the persistent volume claim for stateful application running in the Kubernetes. Workload that are defined through CSI volume plugin are portable across Kubernetes clusters and across the vendors without changing the application manifest. So today, if you see in the market, right, there are multiple companies, offering their file and block storage in the Kubernetes through the Kubernetes architecture, and some of them are listed down here. We have Portworx from Pure. We have container storage from Red Hat, Robin from Robin Systems, Trident from NetApp, and we from the GreenLake also. We have HP has those GreenLake offering. So now this is about the file and block data, right? I mean, Kubernetes is also working on an interface called as a container object storage interface to define a specification for object storage and generate a persistent object buckets. I believe that has come in the Kubernetes release 1.25. And also there are a lot of open source projects that are under CNCF, right from Ceph to Longhorn to OpenEVS. And then you have a streaming data platform called Pravega that provides you the cloud native kind of handling the streaming data at the edge. So this is what I wanted to present. I'm open for questions. Any questions?
Do you have any examples of like the kind of light AI work that the things that are edge IoT might do?
Sorry, I didn't get it.
So the edge IoT devices, like the
Yes.
application things. Do you have any examples of what those are?
I currently don't know, but those could be a very basic AI/ML rules that can be applied on on the video cameras that that runs or into the connected cars. But if you ask me the specific applications, I am not aware.
Yeah, just looking for high level.
Yeah, yeah.
So you mentioned the network edge, you got object storage, blocking files. When would one be used versus another, and how would they be used in the network, or just using an example?
Can you repeat your question one more time?
So your network storage, or your network edge,
Mm-hmm.
has some storage in there. Can you give examples of how that storage would be used at that location?
So it could be, act as a, a local data center for a telco edge. I mean, say most of the network edge will be implemented by the telco customers, right? So now today, you need a data that, basically needs to be locally stored within the telco infrastructure before landing into the main core data center, right? Because you need a data to travel less and to generate low latencies and to solve those bandwidth issues. So I think the main reason behind having those network cloud is to provide, to kind of use it as a local cloud for that entire edge infrastructure.
So if it's not storing a lot of data, wouldn't an HCI solution with storage
Yeah, absolutely. So
object, but what would be the usefulness of pushing an object store out to the edge?
can you repeat that last part one?
So you had object listed, I'm just curious. I mean, I can see object in the core data center.
Mhm.
Why would you have object storage out at the edge since it's more for a highly scalable?
Absolutely. But, as in when, I mean, we are talking about some of the, when you talk about the, bringing those cloud native, applications, right, at the edge itself, right, then, the object is kind of go to more, yeah, so that's what is the future moving towards, could be. Yeah. Okay, guys, if no more questions, thank you. Thank you. Thank you.